What we're looking at here is how we can get instructions onto a computer in binary, so how we can encode instructions. And so let's take a small robot which has the ability to move north, south, east and west. So we've got 4 different options: north, south, east and west. And so we can use binary to encode each of those instructions. So 0, 0 would be north, 0, 1 would be south, 1, 0 would be east, and 1, 1 would be west. So let's say that I write a program. I could write a program such as 0, 0, 1, 0, 1, 0, 1, 1, 0, 1. And so 0, 0 would mean go north. So let's say the starting position was where the robot is now. He goes north. Then 1, 0 would be east. So he goes east. And then 1, 0 goes east. Then 1, 1, which is west. And then 0, 1 down here, which means he goes south. And so there we've got instructions which are here, which are encoded in binary. Now obviously if we wanted to have more than 4 instructions, we would need more bits to encode those. So we'd have north, south, east and west. And we'll also have an instruction called pick up and put down. And so we'll need 3 bits this time to encode these. So it will be more like this: 0, 0, 0, 0, 0, 1 for south, 0, 1, 0 for east, 0, 1, 1 for west, 1, 0, 0 for pick up, and 1, 0, 1 for put down. So now I can write a new program, and I'll start my program up here. So it could be something like 0, 0, 1, then 0, 1, 0, 1, 0, 0, 0, 1, 0, 0, 1, 0, and then 1, 0, 1. So this program here would do the following, and I'm going to make my start point here, and I'll do it in a different colour so we don't get confused. So my program here, 0, 0, 1, that is go south, so the robot goes south. Then 0, 1, 0, that's go east. Then 1, 0, 0, which is pick up, so he picks something up. Then 0, 1, 0, which is go east, and he goes east again. That's the 0, 1, 0 there. And then 1, 0, 1, he puts something down. And so that is our program for doing that program with the robot. Now the question comes, what a processor does is very similar to this, or in fact is exactly the same as this. We get the instructions and we encode them in a binary format. Now, so the way that a computer works is very, very similar to that. And so you have instructions which are stored in RAM. And if you remember, RAM is our random access memory. And it can store data, and it also stores our instructions as well. I am assuming here that we're using the most popular computer architecture, which is called a von Neumann architecture. So both data and instructions are stored in RAM. And the instructions that we have for computers are immensely simple instructions. We don't have things like paint on the screen or draw some nice 3D graphics. What the processor deals with is immensely simple instructions, almost the most simple you can get. So it will be able to do things like move data from memory to somewhere on the processor. It will be able to perhaps add 2 numbers together on the processor, or to increment a number sitting on the processor. And what I'm writing here are opcodes, and these are the mnemonics for the opcodes. So what I can do is I can store a binary representation for these operations or these instructions. And so these might be the opcodes, and then later in RAM I might somewhere have the data which I'm going to use. And they're all sitting in RAM together. Now the processor itself cannot distinguish between these two. There is no way for it to know which is which in a von Neumann architecture, because both the instructions and the data are sitting there. And although I've done these as just 4 bits, they would actually be occupying 8 bits, and so there would be other parts in here. There's no difference at all. What the operating system does, though, is something extra. And what the operating system does is very simple to deal with this problem. And so it divides up the memory into two areas for each process. And one of these areas is called the data segment. And one of the areas is called the code segment. Now, the data segment is read and write, so it's possible for the processor to write to this area. The operating system will let it do that. And the code segment is read-only, so this is where the instructions will be placed that run the program. Now, it's not the computer, it's not the processor, it's not the RAM. That is not stopping it from distinguishing what is instructions, what is data. It's the operating system which is on there, which is making sure that it's not possible for data somehow to magically start writing over code. And if you had some computer viruses before operating systems were able to deal with it this way, computer viruses would be able to somehow get the code to start operating with data, and then it could start executing instructions that you didn't want to happen. That's not how things work now. On a von Neumann architecture, there is another architecture which deals with this in hardware.